Hello everyone, in this video we're going to be doing linear algebraic equations and we'll be discussing how to solve them. So take a look at this example, 2x plus 3 is equal to 9. How do we solve for x? Well, when we say solve for x, we mean find a number that makes the equation true. Okay? Now, when we see this 2x right here, this means multiply. When you have a number that is next to an x like that, it means you multiply. So it's 2 times x. It can be rewritten as 2 times x. And we use this symbol instead of this to differentiate between the variables and the multiplication symbol. So to solve this, we need to look at PEMDAS. A nice way to look at algebra is to do the inverse of order of operations. We need to do subtraction, addition, division, multiplication first, instead of the other way around, doing the parentheses and exponents first. We need to get rid of that 3. Big idea of algebra is to rewrite and undo things. So I'm going to rewrite this. 2x plus 3 equals 9. How do we get rid of that 3? Well, something we can do is undo. We can do the opposite operation. So what I'm going to do is subtract 3 from both sides. And we do it from both sides because we need to keep the equation equal. Okay? That's a big idea with algebra. You need to do the same operation to both sides of the equation to make sure that you won't get the wrong answer. If you do it to one side, you will get the wrong answer. Okay? Now, what's positive 3 subtract a 3? That's just 0, right? So we can leave it as plus 0, or we can just do nothing. Just do nothing, right? That is equal to 9 minus 3, which is, what is that? That's 6. Now, notice how I said this 2x right here, this is multiplication, right? So how do we undo multiplication? We have to undo that operation right there. What's the opposite of multiplication? That is division. So what I'm going to do is divide both sides by 2. I say 2 because that's the number in front of x. We have to undo that 2. We have to undo the multiplying by 2 by dividing by 2. Okay? Now we have x is equal to 6 divided by 2. What is 6 divided by 2? It is 3. So we have x is equal to 3. Now, a big thing with algebra is you can go back and check your answer, okay? You can go back and check your answer. So I'll just put this all in a box. So we have 2 times 3. I'll rewrite this. Get all that other stuff out of your way. 2 times 3 in parentheses. Doesn't matter if it's... We prefer to put it in parentheses. You can write the multiplication symbol. Either works. And then we do plus 3 is equal to 9. Is that equal to 9? Well, 2 times 3 is 6. Plus 3 equals 9. Is 6 plus 3 9? Yes, it is. So we got the right answer. So if you want to make sure you're right, you have to check your answer by plugging in x again. So you take whatever answer you got and you plug it back in. If it doesn't, if you get something like 6 is equal to 9, you got the wrong x value. Okay. Let's try another problem. Let's try 3w, let's just use x's, minus 1 is equal to 14. You can use x's, you can use y's, you can use z's as your variables, it doesn't matter. We usually do x's. Now, let's remember PEMDAS in the inverse. It is not required to use PEMDAS in the inverse, but it does make everything a lot easier. Because if I were to divide by 3 right here, it would make the equation very hard if I divided by 3 as my first step. So I'm going to not do that. So how do we undo? What are we undoing here? You can try the problem for yourself if you like. I'm going to start by adding 1 to both sides. Okay. Very bad 3. So negative 1 plus 1 is what? What is that? That is 0, right? So we can do plus 0 or leave it blank. Let's leave it blank. 14 plus 1 is 15. Okay. Now how do we undo this multiplication? How do we undo a multiplying by 3? Dividing by 3, right? So we have x equals 15 over 3. What is 15 divided by 3? That is 5. Okay. And then we can do what we did before. We can plug in what we got for x, right? So let's do 3 times 5 minus 1 is equal to 14. What is 3 times 5? That's 15, right? Subtract 1 is equal to 14. 15 minus 1 is equal to 14. 14 equals 14. So we did it right. Big check mark for you. Let's try one more example. Let's try 3x plus 4 is equal to 43. How do we solve that? Bigger numbers this time. Well, we have to think about our PEMDAS rule of inversing to make our lives easier. We have to get rid of this 4. So let's subtract a 4 on both sides. And we're doing it on both sides because we need to keep the equation the same. We need to... We're going to get the wrong answer if we don't subtract it on both sides. So 43 minus 4. Sometimes your algebra teacher may let you have a calculator for algebra like this. If they don't, try to work it out. 3x is equal to 39. Well, let's undo this multiplying by 3 by dividing by 3. Get x is equal to 39 divided by 3, 13. It's 13. Now let's check. Three times 13 is 39. Add 4 equals 43. 43 equals 43. Perfect. Let's try a more difficult one. Let's do x divided by 10 plus 3 equals 9. Notice how this problem is different from the others. It is different because we are dividing by a number. Okay? Note our PEMDAS rule. Let's do subtraction first, like we've always been doing. Subtract 3 on both sides. Get x over 10 equals 6. Okay? Now this is the part we haven't been looking at. How do we get rid of division? What is the opposite of division? Well, the opposite is multiplication, right? So what I'm going to do is, instead of dividing both sides by 10, I'm going to multiply both sides by 10. Okay? This 10 is being multiplied to the dividing by 10. So what does that do? That will cancel them both out. That will get rid of them, leaving it with just our x. So x is equal to 6 times 10. Just drag the 0 over to the 6, and then we get 60. X is equal to 60. Now, we can still check our work here. By plugging 60 back in for x. 60 over 10 plus 3 equals 9. 60 divided by 10 is 6. 6 plus 3 equals 9. 9 equals 9. That is correct. Okay. Try this one out by yourself. X over 3 plus 1 equals 5. I'll give you a moment to try that out. Now, by now, you should know that we just have to get rid of this 1 right here. So, plus 1 and minus 1 makes a 0. 5 minus 1 is equal to 4. Now, how do we get rid of dividing by 3? We have to do the opposite of dividing by 3, which is multiplying by 3. A 3 for a 3. X is equal to 4 times 3, which is 12. And then we can plug our answer back in. 12 divided by 3 plus 1 is equal to 5. Is that right? Well, 4 plus 1, 12 divided by 3 is 4. I'll just put this around the box. 12 divided by 3 plus 1 is equal to 5. Is that true? 4 plus 1, is that equal to 5? You bet it is. 5 equals 5. That's right. Let's try another one. I'll use x. $10x plus 40 is equal to 10. How do we solve that? Well, we just have to subtract this 40 on both sides. 100 minus 40, you can use a calculator if your teacher allows. If not, try to work it out. That is 60. Now, how do we get rid of this multiplying by 10? We have to divide by 10. The 10s go away. 60 divided by 10 is equal to 6. And then we can test our answer. 60 plus 40 does equal 100. I'll put a couple practice problems on the board right here. See how many you can solve. Take your time if you need. We'll do, for the last one, we will do, let's do this one. Let's do a challenge problem here. So we have x over 9 minus 8 equals 1 for the first one. Put a 1 on that. And then we have 7x plus 2 is equal to 30. And then we have 6x minus 12 is equal to 48. And then we have x over 6 plus 4 is equal to 4. Give you a moment to try these out. Pause the video if you need. Let's look at this first one. X over 9 minus 8 equals 1. How do we do that? Well, we have to undo subtracting by adding. Remember our PEMDAS rule? We have to inverse the order of operations. We have to do this adding and subtracting first to make it easy. So let's add 8 to both sides. X over 9 is equal to 9. Now how do we get rid of the dividing by 9? Well, we have to multiply both sides by 9. Because that's the opposite of division. A 9 for a 9, 9's cancel. X equals 81. And then you can plug that back in to check that answer if you'd like. Now let's do the next one. Let's do 7x plus 2 is equal to 30. Let's get rid of that 2 by subtracting both sides of the equation by 2. 30 minus 2 is 28. Now what is 28 divided by 7? How many 7s does it take to get to 28? That would be 4. X is equal to 4. Let's try the next one. 6x minus 12 is equal to 48. Well, we have to add 12 on both sides to get rid of that subtraction. Now, how do we undo multiplying? You should know by now it's dividing. X is equal to, how many times does 6 go into 60? That would be 10. So 10 is the answer for 3. Let's try the challenge problem. X over 6 is equal to 4. Sorry about that. X over 6 plus 4 is equal to 4. How do we do this one? Well, if we subtract both sides by 4, get x over 6 is equal to 0. Now this may look weird, but let's keep doing the process. We multiply by 6, get x is equal to, what is 0 times 6? 0, right? Now, let's go back and check. Let's check our work here. So let's plug in 0 for x. We have 0 over 6 plus 4 is equal to 4. Now, a big thing about 0 and dividing is you can have a 0 on the numerator You cannot have it on the denominator though. Since it's on the top, that works. If it was on the bottom, if it was like 6 divided by 0, that would be undefined, which you'll see more once you progress in math. So how many times does 6 go into 0? That's 0. It will always be 0. When you have a number going into 0, it'll always be 0. Plus 4 equals 4. 4 does equal 4. So that is right. I hope you found this video helpful. If you have any questions, please leave them in the comments. Thank you.